In this video, we'll talk about how you can use CLP's new MCP server to enhance AI-assisted failure diagnosis at scale. Nowadays, AI-powered coding tools allow developers to push code at unprecedented speeds, and the bottlenecks posed by debugging and failure resolution are growing even faster than the codebases do. So naturally, engineers also want to use AI to debug production failures. Production systems can generate gigabytes to petabytes of logs, and diagnosing a failure in these systems can require analyzing logs spanning several days. Yet even the best LLM models today have a maximum context window of just a few megabytes, about 1 to 2 million tokens, so you won't get anything meaningful from pasting those logs into a chat window. So then, how do you provide an AI model with the breadth of context needed to make a diagnosis? CLP is an open source tool that losslessly compresses your logs and lets you search through them without decompression, which makes it well suited for the demands posed by the scale of data involved in production failure diagnosis. Engineers using CLP at scale from companies like Amazon and Uber have also requested MCP server support so that they can build agentic workflows on top of CLP. In response, starting with version 0.6, CLP includes an MCP server, allowing AI agents such as Claude Code, Codex, Bedrock, and others to interact directly with CLP. You can also provide your AI agent with additional context from other data sources, such as source code or metrics, to fully leverage the LLM's capabilities. When you send a diagnosis request to your preferred AI agent, the agent passes your request to the LLM. Then the LLM constructs KQL queries based on your request, and the agent sends them to CLP's MCP server. The MCP server executes these queries on CLP and returns results to the LLM quickly and efficiently. The LLM analyzes the results and constructs the next set of queries. This workflow repeats until the failure is diagnosed. We tested popular AI agents with CLP's MCP server using Claude Sonnet 4.5 on 14 debugging and forensic tasks, including 11 complex production failures, which typically take months to resolve. We found that with CLP, the agent was able to diagnose them in just minutes with 78% accuracy, while remaining token efficient. Let's see CLP's MCP server in action on a critical HDFS bug, HDFS 11896. This HDFS cluster was reporting an abnormal spike in the non-DFS capacity used metric, which keeps track of how much non-DFS data is stored for the cluster. After we ingest the logs from the HDFS cluster into CLP, we can connect the agent to CLP's MCP server and then prompt it to diagnose the issue. The agent confirms the spike we observed in the metrics dashboard, and it investigates. The AI presents its first hypothesis. Certain storage volumes marked as failed due to network connectivity issues are being counted towards the non-DFS capacity. We can click the link to view the log in the context of the log file. This opens CLP's log viewer at the relevant logs. We can see that the failed storage is returned to normal during later block allocations. So we prompt the agent to continue its investigation. We repeat this process until the agent provides a hypothesis we can't refute. When a data node is marked dead due to missing heartbeats, its non-DFS used value isn't cleared. So when it comes back online, the stale value is added to the new value during re-registration, causing the spike. We confirmed this as the root cause by instrumenting the source code. CLP's MCP server is powering agentic log analytics workflows at a number of Fortune 500 companies, helping engineers leverage AI agents for faster and more effective operational troubleshooting. This is only the beginning, as CLP becomes the AI-native logging platform. Thanks for watching, and as always, feel free to reach out to us on GitHub or Slack if you have any questions.